Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 10.1, Problem 4. 10.1, Problem 4, it says consider the graph of the function shown below, and there's a drawing of a graph, and then there's 4 questions about that graph. And the first question says, if x is 4, what is f of x? And when you deal with functions, it's good to remember that the terms f of x and y are always interchangeable. So instead of reading part A as if x is 4, what is f of x, you could read that as if x is 4, what is y? It's the same question. So if you look at the graph, there is a point 4, 0. It has an x-coordinate of 4 and a y-coordinate, or f of x coordinate, of 0. So the answer to part A is 0. And what this means is if you put in a 4, what you get out is a 0. The x values are what you're choosing to put in, and the height that you go up or down to get to the graph is what the function is giving you as an output, what you get out. Part B says if f of x is 3, what is x? And again, you can change that question basically to if y is 3, what is x? Because f of x and y are interchangeable. So as you look at the graph, you will eventually see that there is a point on the graph labeled that has a y-coordinate, or f of x coordinate, of 3. So the x-coordinate that goes with that is 5. So the answer to part B is 5. And again, you can interpret this question as, instead of if f of x is 3, what is x? You can read it as, if the function gave you out a 3, what did you put in? So if you got out a 3, you must have put in a 5. Part C, what is the domain of the function? The domain is what you can use as an input value. And in terms of seeing the graph, it's what x values are covered by the graph. So the first x value on this graph is -4, and it continues along until the very rightmost point on the graph is labeled with a point that has an x-coordinate of 6. The y-coordinates don't matter in terms of determining what the domain is. So the domain is from -4 to +6. Now that can be written in a variety of ways mathematically. You can use the bracket notation, -4, +6, a bracket on both. You could have -4 is less than or equal to x is less than or equal to 6. However you get the point across that it covers x values from an x value of -4 all the way up to an x value of +6, that's the domain. Part D says, what is the range of the function? The range of a function is what you can get as an output value from the function. And in terms of the graph, it's what y values are covered by the graph. Now, the y value is covered by this graph. The graph has, the lowest point on the graph is labeled 2, -2. So it has a y-coordinate of -2. That's the lowest y-coordinate you can get, or the lowest output you can get. And the highest point on the graph is labeled 5, 3. So the highest output you can get is +3. So the range, or what you can get as an output, is from -2 to +3. And again, in class, if you wrote this on an exam or a quiz, I'd give you credit for that. It's not the most mathematical way you could write it. You could write it -2, 3 with a bracket on the -2 and a bracket on the 3. If you're familiar with the notation, it's actually less writing, though you've probably seen it in a previous class. You may have forgotten it. And you could also write something like -2 is less than or equal to y is less than or equal to +3. That would be happy with any of those forms.